Operation
and I'm going to start streaming, and then we'll kind of figure out the audio stuff.
What's the difference between these and different colors? Like,
No, that one wasn't even supposed to grab. That was a new bag we have. If you try that, then we have to still grab it. We have these bags, and we'll just try these bags.
oh,
They're the same thing. It's nothing. It's just a different packaging.
Let's see.
But nothing. We wanted to see if
I
that bag is
have.
good. If it's actually sealed properly.
I'm muted.
But please, if you try it, it's okay.
You're unmuted.
Success then.
Do you need us quiet?
Can you mute your computer? Yeah. All right, this seems to be working. Let's see if anyone streaming can check.
Oh, there's a below season. I didn't realize that. Of course there is.
I'll try it on my phone just to make sure, because nobody's answering.
So quiet and there's a humming. I feel like I'm
Can you say some stuff?
We're looking at the Virtio Oasis spec, version 1.1. There was a version 1 that wasn't good enough, so they had one
See,
on
it might be delayed.
So you got it 1.1, so it wasn't too bad. Just do that.
No, just, there is a 1.2. We're thinking about it.
delay is fine. That's
Okay, yeah, it
that's
sounds
fine.
good.
Cool.
Delay is fine.
Yeah, let me just go full screen here, and then we'll get started. Where's my mouse? Okay, now I gotta do like a spiel, and I haven't prepared for it. I guess I'll do the same spiel I always do. Yeah, are we all closed up? Okay. Yeah, so welcome everybody. This is Below Sea Level. The goal of this project is to find people who are doing systems programming in New Orleans and get them to talk about it, and also maybe get people who are interested in it, want to try some things, to talk about that as well. So, our goal is really to kind of create sort of a fun, inviting place to learn some of these concepts. And this is a project started by me and Aaron, who's over there. And we're always looking for speakers, so if you have ideas for talks, come talk to us. Or if you don't have ideas for talks, come talk to us if you want to talk. I think I badgered Neil into doing this. Yeah, so today we have Neil. It's an off-cycle month. Usually we're the first Tuesday of every month, but we took this month off for July 4th. Next time we have my friend Dan Phillips. He's going to talk about like virtual file systems, and it's going to be our first remote speaker, so that should be interesting. I don't think we have someone for the September, but then the next one, Austin's going to talk about some cool Sega stuff that looks really awesome. Really excited about that. And I think for the rest of the year, where slots are open, so come talk to us after, and if you're interested, or if you even know someone who might want to talk, yeah, let us know. Let's see, what else? Yeah, so I'll just hand it over to Neil. I'll let you introduce yourself, but yeah, let's hear for Neil.
Right. So I'm going to talk about Virtio, but I'm really not going to talk about Virtio. Oh, you lost.
No, I got it.
So I'm gonna talk to ChatGPT with everyone.
Sorry, I lost the screen.
The reason is that Virtio is kind of cool, but like extremely boring. And I'm gonna send everybody the spec, and I want you to read it by next Tuesday. But it's really not that interesting. But it's interesting in the way that it kind of funnels into systems programming and just kind of what I wanted to talk about today, which is basically that, like, I'm sure maybe like a lot of you, or maybe none of you, but I I'm a little bit old. I started out, I did a computer science degree. I learned all the things, went through linear algebra, I don't remember any of it. Like discrete math, nope, nothing. Like I actually did a operating systems class, don't remember a single thing of it. Did like full stack like programming for a very long time, and it was awesome. And then a friend of mine was like, do you want to write like low level systems programming and try to make a business out of it? And I was like, yeah, that sounds great. So that was a poor decision on my part, but it did sort of force me into kind of coming back to some of these fundamentals. And a lot of people that do like front end, you know, full stack development are like, whoa, that like low level system stuff, like don't even get me started. Like I can't even like break into that. That's like super complicated, super hard. And while it is in some ways, in a lot of ways, it's actually not hard at all. Like, it's just tedious. Like, it's like cutting your lawn with scissors. Like, it's like, I mean, so a lot of what you have to do is just learn, like, you know, we call our day-to-day jobs Linux bullshit. And like that pretty much is what it is. And there's a lot of layers underneath that as well. So we're gonna ask ChatGPT some questions. And I don't wanna make this like too boring, but it is kind of interesting to kind of come at it from this perspective, at least for me, because like my brain, like I'm sure some of you guys are like, guys and gals are like really like kind of honed in, can like translate hex into decimals into English like it's nobody's business. So if that's you, it's good on you. For me, that is not me. Like I have questions and I want them answered. So I'm going to ChatGPT and we're gonna find out some answers. Let's see. See what it says. We're not going to read these like in totality, if it even answers me. Which boy, this might be where we recurse ChatGPT into oblivion. So
Could you make it a tiny bit bigger?
yeah.
Oh, can I ask a question?
Yeah.
Which version is this?
We are on 3.5.
Okay.
All right. We're gonna just reload.
So it's a 2-year-old definition of computer.
Yeah.
So.
Oh boy, am I off the network? I'm not off the network.
That might be it. Well, no.
No, you wouldn't be streaming if you were.
Oh, that's true.
Well, I guess you could be. I could be.
Okay.
That might.
We're gonna give ChatGPT a minute, and I'm gonna pivot a little bit to honestly, like my my whole spiel is kind of based on this. So let's try it one more time.
It's green now.
All right, well, let's chat for a minute while ChatGPT finds out if it's a computer or not. So, kind of where I started was like, I have like, I think a lot of people are like this. Like, you either sort of like come at computing from the framework where you can do like I don't know. It's a lot like math, right? Like some people are just good at math. They can do chess moves. They can do like, you know, computations in their head. They are just kind of naturally like aware of how systems work and have like a kind of that mindset. Like, and there's other people like me, which like, you know, I don't want to think of myself as stupid. I'm pretty stupid, I'm sure, but I'm not that stupid. So like, I kind of come at problems like at a different angle where I'm like, you know, if like, the reason I asked ChatGPT this question, what is a computer, is because I'm kind of wondering what. There we go. Okay. I guess it woke up.
It had to go find one.
So.
Yeah, I've been asked that before.
Yeah. So this is the way my brain works. A computer is an electronic device. So when I read those words, like I stop immediately. I don't even read the rest of this. And in fact, I'm just gonna tell it to stop because like I don't care. Like I don't even know like what is an electronic device. Like what is electricity? Like that's where I immediately go. And like that is not an easy question to answer. So, I mean, I'm gonna ask it, what is electricity, because I wanna know what an electronic device is. And like, it's not gonna be this tedious for the entire talk, so just FYI. But like, the point being, like, it's just, when you're doing systems programming, like, it always like, amuses me when people are like, I can't get in there, like the Linux kernel, like no way, like, you know, all that low level stuff, like, is not for me. I'll just code in React, and I'm like, okay, well, like, I mean, I think you've chosen the more difficult path, because like, once you get down to it, like, systems programming really boils down to, honestly, like, just writing and reading like memory segments and like things like that. And the reason it's hard is not because it's like conceptually difficult, although, you know, I'm asking it what is electricity, and it can't come up with an answer. But you know, electricity boils down to like a lot of like subcomponents that like I can't understand and will never understand. There's like electrons, I don't even know what that is. So there's always like layers below like what you understand that you have to build on, and systems programming is just another layer on top of that. So a lot of people are kind of turned off just by the kind of pure like moniker of systems programming, but I think more people should embrace it because it's actually not that complicated. And once you get into it, it's more sort of convention than anything else, because you're really just like dealing with just bits and bytes and writing. Like, the reason it's hard is because it's hard to debug. So like, so I would say we're gonna get to Virtio at the end because it's really boring. Y'all don't want to hear about it. But the reason like systems programming is hard is just because it is really hard to debug, and you would think a lot of it is because like there's these complicated concepts and like things you would never understand in a million years, but it's mostly just a guy in like 1986 that was like, I'm gonna just like say this address space in memory just doesn't exist. And you're like, oh, okay, well, that's cool. And when you try to read from it, you don't get anything except like just like a kernel panic or something. Like, so like, so yeah, it's a lot like that, and Virtio is a lot like that, and kind of even booting, like, I was gonna ask ChatGPT, like, you know, a lot of questions about like, how do you even boot a computer? Like, I have no idea. Like, I don't know. Like, I guess you put something in memory. Like, how do you put it in memory? Like, I don't know. Like, I mean, I guess like some piece of electricity puts like something in a chip, and then the chip reads from another. Like, you sort of get down these like roads where, you know, you have to embrace abstractions at some point, and just trust that other people have figured this out. And I guess the people at Intel and AMD have figured it out, because I do have the PDF of the Intel spec. I would bring it up, but it's about 5,200 pages. And if anybody wants to read that, you're welcome to it, but I don't. And I know what a jump instruction is, but that's about as far as I want to go. So to do systems programming, it's not always just that you have to understand every single facet of every single thing. Like, so I would say, if you're hesitant about jumping into things like the Linux kernel and hypervisors, which we wrote one, and I was very hesitant about my abilities to do so, and I still am to this day. But it's actually it's not that hard. So I would say keep digging, read. Like, the Linux people are weird, like, for sure, but like they document pretty well. And so like a lot of like, so when we wrote a hypervisor, which is basically just like using like KVM, which is already like it's basically a built-in kernel feature in the Linux kernel to be able to take. Actually, let me back up a little bit, because this is what I wanted to talk to GPT about, if it would talk to me. But I was thinking about like why we need, like, what is virtualization? Like, why do we even need to virtualize hardware in the first place? Like, why don't you just have like more hardware? And I guess it's like a physical limitation, like, for sure. So we've got all these like big servers, they're beefy, they cost a lot of money, but we can't make like a billion of them, which if we could, like, that would be awesome. But we can't, so that's why somebody wrote 5,200 pages of documentation and a specific like transistor configuration and a CPU to like make mini computers out of like mini being in the small sense, out of mini computers. So they took all that and they spent a lot of money, I'm guessing, a lot of brain power to do this, and it is interesting. Oh, sorry, didn't die. Let's see. That's a good question. The $20 was not worth it, but so this is funny. Let's talk about this. Computers can be virtualized by a process called virtualization.
Can
Okay.
you go a minute, please?
Yeah.
Can you magnify it like one?
Okay. Is that better? But yeah, so I mean, I work for a company that does like hardware virtualization because we want like our goal is to, we can't have better hardware, but we can have a lot more hardware, like, if that makes sense. So we're trying to get you a laptop better than this, which just went to sleep on me because it wasn't plugged in for a second. So while we're doing development, like, we want access to machines that are better than what we can ever get, like in any kind of physical scenario, like, for the most part. So that is a long answer. And I'm gonna back up a little bit too, because how long have I been going? If I check my phone, I'll just try to make sure I'm not going long. But like, part of what I wanted to talk about with these answers is that, like, you can kind of go down the rabbit hole. Like, what is, and this is the problem with some of these, like, and it's not ChatGPT's fault, it's our fault. Like, we don't explain computing in ways that are like coherent. So I mean, this sentence right here is like a complete like.
I wrote that in high school before.
Yeah.
The second sentence is better.
Yeah, exactly. But even like the official documents are pretty bad. But so now that it's answering me, like, I guess I'll back up a little bit, and it's just like, what does it mean to virtualize like a machine? Like, so you've got computers, like, and maybe it'll answer me this time. Let's see. What am I gonna ask? Well, I'm not gonna ask it. Let's ask this question. Like, computers take advantage of the fact that, like, there's electricity, right? And like, let's see. I think I asked this earlier and it didn't answer me. But like, they just take advantage of the fact of like physical sort of manifestations to do like addition and subtraction and like things like that, which is really weird. And then like, we take advantage of that fact to kind of make like mini computers out of it. And like, the thing is, you can go like so far down the rabbit hole that like, as ChatGPT is doing right now, that you almost have to focus on the kind of things you want to do as a system, and those things are not like and that's why Intel has done this. So, so what we try to do is take like the fact that you can, we'll get into VirtIO now, I think. So essentially, if you can make a computer within a computer, you want to take those hardware components and farm them out. Like, and a lot of our products are like now registered under the domain name .farm. So that's kind of like what we're trying to do. And the way you farm those out is to kind of leverage these systems that let you kind of take all these hardware devices and pump them through essentially RAM. Like, I guess like you just took memory and said, we can use this like just however we want. Like, and so the CPU could say, I want to take this space of memory and like it's just for me to talk to a hard drive on a computer that is now virtualized on hundreds of VMs, but this VM only gets like this amount of space. So this is kind of the way VirtIO works, is that once you take a CPU and you kind of tell it where the memory space is, first of all, you can take that memory space and boot Linux, which is really like just taking like a little bit of data, jamming it into a piece of memory, telling the CPU that it needs to look for that piece of memory, and then read it out and then start the boot process. So like from that point on, like Linux thinks it's only in like this little like barrier of memory. So that's essentially how virtualization works. Like it's not completely it, but like for all intents and purposes, like you're dealing with just like memory barriers. And I'm sure some of you have heard of like Spectre, which is like just the so that was a kind of like just, I guess, security flaw in the kind of virtualization layer of the CPU, and it allowed for a lot of bad stuff to happen. So, but that notwithstanding, they fixed it, and it's still to this day like how most virtualization happens. Like it's really just like memory spaces and the way the CPU can look at them and read basically just buffers of data, like ones and zeros off the stack. So, so that's kind of why VirtIO is not very interesting, because like it's kind of a way to say, all right, my hard drive is like reading and writing data, and it's got to go somewhere, and the kernel is just like, all right, so I've got this CPU that tells me where I can put it, and I've got this kernel like kind of instruction, or this kind of kernel module that says where it can go, and then it's up to you to kind of read it and write it. And if you don't read it and write it correctly, like you're just done, you're dead in the water. And you have no idea why, because you just read a piece of memory and you're expecting a piece of data, and it's just not there. It's not the shape you want, and it doesn't actually exist. So that's like the hardest part of like computer virt, in my opinion. Like just dealing with it from a very like kind of superficial level of just writing like kind of hardware virt things. But yeah, I mean, I think the reason I wanted to dig into like ChatGPT at this level was just to which I've already kind of talked about, but like just say that like it can go down to the smallest levels, and it almost seem like kind of useless to understand how it works, but
Could I ask a question?
Oh, yeah.
Regarding abstractions, like,
actually this is
why did you not just in building getenv? Why did you not just use all the abstractions that we already have for virtualization that other people take care of? Why
Like Firecracker?
VirtIO? Yeah, all sorts. There's all sorts of things. There's Firecracker. There's Docker containers. There's
so
why build a hypervisor?
there is, let's see, because you can do pretty cool stuff like this. So, you know, a lot of this is abstracted under the hood, but when you write your own hypervisor, you you deal with all the virtue stuff, which is just really just figuring out how to read memory from like allocated spaces that are given to you and kind of like addressable memory tables, and you just read it and you write it, and it's really annoying to debug, but once you get it right, like it kind of works. But when it works, you get to do some cool stuff on top. So, you know, this code is kind of, abstracted, but let's see.
You
Think-
can magnify just a little
Oh
bit.
yeah. Say you have a block device that you want to write to. Say like you're in a virtual machine, right? So, you've created a virtual machine. You've allocated a storage device to it. Like that could be a 100 gig drive that's on /dev like VDA, and you mount it, and it's virtualized based on kind of just the semantics of how VirtIO works. So anything that comes from from the host, which is the kind of machine that's virtualizing these devices, into the guest, which is like just kind of your individual machine that you're kind of isolated from the rest of the universe from. You can kind of intercept, so to speak, those block device writes and do some interesting things with them. So what would you want to do? You might want to write them to dev null, which would be kind of annoying for your users, but it's certainly possible. You might want to write them to AWS S3. That's going to be really crappy performance, and it's going to be terrible, but if you control how every block comes in and out of your virtual machine that you're running, then you have control over where you're going to send that, what you're going to do with it. You could encrypt it with a user's keys that you can't read, things like that. You could write it to a database, which is weird, but you could definitely do. But it gives you very fine-grained control over like how things come through. So the block device is like the most kind of obvious one where you would want to do those things, and so VirtIO gives you a way to like intercept those those kind of buffers coming through, do what you want with them. And there's different kinds of devices in VirtIO. There's a console device, which is pretty useful if you want to see things coming in and out of a computer that you're typing input and output into. So that's good. There's a network device, which is pretty interesting and kind of complicated, but you might want to rewrite the Ethernet frame completely in that. So I think those are the kind of reasons you would write your own, those are the reasons we wrote our own hypervisors, because we want to have pretty fine-grained access over those things and be able to throttle, kind of handle all the potential issues you might have if you're just like handing out machines willy-nilly to the entire world for them to do whatever they want to do with. Another reason is you might want to virtualize particular kinds of devices, like an ASIC, which might just be a pass-through, right? Like if you've got a Bitcoin miner that you want to virtualize and maybe throttle like just the kind of IOPS that are going through like a device like that. You can actually write your own kernel module for VirtIO, patch the kernel, like put it on servers and do that. GPUs are kind of a good thing to be able to virtualize right now, because you can throttle those. Or I say throttle, but like you really do anything you want with them. Like it's really just like kind of frames coming over the wire. So the good thing about writing your own hypervisor that's integrated with your system is that it's integrated with your system. And yeah, if you want to kind of do with it what you will, then it's nice. And there's no reason you couldn't fork like Firecracker and do that. But yeah, we think we've got a pretty good kind of subsystem for doing virtualization, which is hopefully a good business to build on top of, but we'll find out. Yeah.
So are you going to be offering up some of this as like APIs for other people to customize and extend and build their own stuff, or is this purely internal code base and it's your own system? Or
Well, so our products like that we're looking to, so our initial like kind of reason for building this was that we wanted to have like better development environments like in the cloud, right? Like we wanted to be able to like do, you know, have like a petabyte of storage and have like, you know, 256 gigs of RAM, like just like beefy machines and like big internet access and like, and you know, just have a better experience than we thought we would have with our laptops. And a lot of, John and I had both dealt in like onboarding at large companies. It's a big pain. And so we were like, you know, you're never gonna like eliminate issuing laptops to people. Like people still have to type into something, right? But our goal was to perhaps like make that onboarding and maybe even decommissioning, sorry guys, process kind of straightforward. So that was a large part of it. And a large part of it too, and this is becoming more salient, is that we want to provide access to like developers to have like access to large like data sets that they normally might not have, like ACLs or like, you know, it just doesn't fit on their machine, or things like that.
Which is becoming a thing soon.
Yeah.
Now.
Right, and you know, with AI, like just being able to, honestly being able to like train even a small data set like on a model, like just to experiment, it's still pretty like, it's still pretty expensive to train these models, but I feel like even if one of these NVIDIA new kind of GPU is just a single one, you could at least experiment with, and you don't have to, I mean, they're like $8,000 or something. I mean, you're not gonna buy one for every developer, but if you kind of can parcel them out and be like, hey, I wanna try this out for a couple hours, or and it's not even like, it's a nice thing about this, it's not even like parceling it out for a couple hours. You can literally just segment the things. Maybe training the model takes like another day or two, but like you're just kind of sitting there. Another part of what we are looking to do, we're calling it like repo farm, where you have maybe a fork of an open source project, and you can just like SSH into it, like, or just access it via like VS Code, and maybe even a maintainer can go in to your like NV and be like, okay, I'm gonna run the test and let's see what you did. Like, I'm gonna test this out before I merge it, and you know, the merge is kind of dependent on like that NV, maybe even like posting a hook back to GitHub, that kind of thing. So that's what we're exploring as well. And in the WASM space, we're looking for.
Yeah, I was going to ask you about that.
Yeah.
I was going to wait until after to harass you.
Yeah, no, I mean, well, just functions as a service is like
Yeah.
kind of a thing. Fly is, I'm sure everybody's familiar with Fly, kind of a Heroku kind of successor. But yeah, Fly is doing a lot of this. Like, I mean, I know they use Firecracker because they tell you in their logs that they use Firecracker.
Yeah.
So you know, there's potential there. We're not looking to get into that like kind of hosting space, but yeah, it's a gamble. But we think, you know, hardware virtualization is something. I guess like what we talk about all the time is like there's like what, 3 or 4 clouds now. Like we feel like there's gonna be like individual clouds. Like there's gonna be a cloud for this, cloud for that, cloud for the other thing, and we want to make a cloud for developers. So anything we can build on top of this infrastructure that is good for devs, like, is what we're.
So yeah, just to be clear though, like this is not what you're saying. Like this is not available. Like using like AWS, it doesn't give you the primitives to be able to run something like this, right? Like this runs on people's actual physical devices that they own.
No, actually. I'm sure, I don't know if you all have heard of like code spaces, GitHub code spaces. Google just launched a product called, I think, Cloud Workspaces. Like REPL.it is like kind of adjacent to this, but code spaces is like containerized and kind of like very specific to the project. Like that's kind of their bread and butter. Google Cloud Workspaces is more of a machine, but it's still a bit limited, and honestly, it's really expensive and kind of a pain.
But you can't run like a hypervisor on any of these, is what I'm saying, right? Or can you?
Oh, you can do nested virt on ours.
Oh, you can,
like,
really?
why not?
Yeah. So our philosophy is this is a machine that you can do anything you want. Like, and maybe that's like a bad idea, but like that's what we wanted to accomplish. So there are two things we wanted to accomplish. Like this machine that you can have in the cloud, that you can have access to at any time, in any way you want. Like we can, like there's ways we kind of like set up the process management. We're gonna have a website. You can access your entire machine from your phone if you want. We're looking at ways to, like, this is not a good idea, but we're looking at ways to take Apple's new spatial kind of visor to do like some things there. And a lot of the ways we engineered the system is to basically like spawn processes, proxy the input output, and have that available in like any format that makes sense. Now, obviously, the best way to, or not the best, but like the most obvious way to do that is like SSH. We can do things over the web with like Xterm.js, like do things like that. But we really wanted the ability to take a machine or an ecosystem.
Gotta keep it alive.
And oh shoot, sorry, I gotta fix that. Take that. Take your machine and be able to access it anywhere from any device. And while it's going to be pretty kind of straightforward, just use it from VS Code or SSH, or if you SSH in and you like Vim or Emacs, your dot files will be there. Like that's fine. If you VS Code in, we'll kind of copy your settings from your. If you sign up by GitHub, you'll have like. All your settings moved in from there. So.
But where? What I'm wondering is like, where's the hardware live? Where are you running this?
Oh, so I was gonna say I'm not at liberty to say, but I'm absolutely at liberty to say. We use we have like we built like iPixie systems to like boot and sort of like kind of run bare metal hardware from scratch. Like so, if you dial out, like if you have a IPMI or something like a bare metal server that you can point at a destination, which is iPixie.getenv.systems, and you point your hardware at that, and you're a registered customer, and you have a bare metal machine, then that bare metal machine like hops on and just becomes part of your like ecosystem, right? So that's like a way that you would do it as a kind of B2B like for us, but as B2C, we leverage bare metal servers like Equinix Metal, Vulture. There's really not many more. Amazon's way too expensive for us to use, but it's the same idea. So we leverage bare metal to kind of just set you up. Like we run, like I wonder if I should get everybody to sign NDA on this. We run a process.
This is streaming online and recorded.
No, we basically have ways to know when you're requesting a virtual machine from one of our hosts, and we will place you on that host depending on the spec that you want. So if you want 1,000 GPUs and you have paid the requisite price, then you can go over there for an hour or two and run a training model. If you want access to sensitive data for a minute or two, then you can get your VM migrated to a machine that has like hackles for that kind of a thing. And honestly, like the migration process is pretty cool. Like you can we really wanted it to be that you could move like wherever you wanted to do whatever things you wanted to do. And I feel like a lot of, like, at least my experience, like a lot of development companies are just like kind of like waiting for you know, ways to get access to things that you want. So we wanted that to be more straightforward. So yeah. Now, to answer your question, that you're running on a bare metal machine.
Okay.
Somewhere in the cloud.
I see.
Hopefully very close to you.
So what's the pricing model?
So that's a great question, because one thing we did not want to do that we saw a lot of people doing is metered pricing. Like, we will never, our company will go out of business before we do metered pricing. So so you know, it's going to be like, you know, individual wise maybe like $15 a month. Teams wise might be $25 a user. We're still playing around with that, and a lot of it like kind of depends on, you know, how we see things shape out. We're very early stage at this point, but we will never do metered pricing for sure.
So is that like unlimited access for $15 a month for like a developer, or is that like you get $15 a month for like a small CPU? And
Like
if you need more,
So
yeah.
it would be great to get feedback on this, because one of the things we thought was that we also didn't want to spec things out by like hardware, even though I know that's like how everybody kind of thinks, and for good reason, because hardware matters, right? Like, but we really wanted to kind of explore a model where, you know, when you're reading Stack Overflow or Reddit, like, you don't really need like 28 like vCPUs, right? When you want to compile like the Linux kernel, like, you might need those, right? So a lot of what we're doing is kind of doing like extensive monitoring on your system while you're using it, and seeing if we can explore ways in which we move you around and allocate. Another reason we wrote the hypervisor is so we can do this. So we can allocate more resources as you need them, but not necessarily like, you know, charge you by the millisecond or something like that, if that makes sense. So it's a bit of a gamble for sure, like, you know, and open to abuse for sure. But like, you know, if I think we have a good customer base, and we have, you know, decent pricing models that make it you know, not that susceptible to abuse, then we can kind of do that.
So what's the UI like the experience of, like, you know, there's a huge difference between no network between me and my IDE and a network between me and my IDE. You know?
Yeah. You're talking about like how you like
me, my developer experience, my user experience as like I'm coding, I'm in VS Code on your hypervisor versus like I'm on my VS Code on my Mac.
What is your primary development or IDE?
I use VS Code.
Yeah. So I mean, the way we're exposing it now is via like primarily like SSH. So VS Code has a remote SSH extension, and that will work just fine like with your engine. So it'll feel exactly like you're working in VS Code, but this is how we use it. We use it like internally to like kind of develop on it. So I believe like Eclipse has something like this. You know, obviously with Emacs and Vim, like you can just set that up like on a terminal and it'll work just fine.
So there's not like a lot of lag in between like typing and stuff like that, or
the latency is not bad, and part of the reason we do this too, we actually will move your VM as close as we can to where you are located. So we do like some just basically like just trying to figure location based like placing of your VM. So even if you move to like LA like tomorrow, like we would start to place your VM in LA as we kind of determine.
are you guys
Is
testing
that-
like different users, like Cox Cable versus AT&T Fiber versus Elon Musk Net, you know, like
No,
how
we-
people are receiving?
We kind of leverage like the BGP like sort of like functions of the bare metal services that we use to place you. What's up?
Do you sort out live migrate?
Yeah.
Oh, cool.
Yeah. Yeah, it's tricky, but it's not terrible.
What's
we actually
Where, like, even, sorry, live migrate means moving from one hypervisor to another, or else. But how do you deal with like specialized hardware with that situation? Like, you're moving from like, you know, something that has like, you know, NVIDIA GPUs over something
Yeah, so like we have a wide kind of, it will depend on like, so basically our base developer kind of image like supports all this, and our kernel is pretty wide. Like, there's probably like we're, again, like very early, so like there's probably scenarios we haven't come up with, but our kernel and our sort of base root, like FS, we're hoping can handle all those scenarios. But certainly if something comes up, we'll look at it for sure. Yep.
I was asking, where does that, what layer does the bound, like the location-based like migration happen? Is that in the hypervisor level? Like,
No, that's actually at the edge level. So we essentially maintain like either SSH or a web or just whatever connection level you're on. That holds a connection to the proxy layer to the VM. So if your SSH, so basically like if we migrate your VM, the SSH connection stays open, and the VM goes somewhere else.
yeah.
So it's a little bit transparent, like it's kind of nice in that respect. But yeah, we keep connections at the edge level and then just proxy input and output and buffer it if we're migrating and it takes a minute or two, or never will take a minute or two, but if it takes a few seconds, then you'll feel that lag as you migrate, but the connection itself is not good.
Could you repeat the questions? Because I forgot we don't have a mic, so when someone asks a question.
Yeah. What was the last one?
The question was about, he had
At
asked
what
about,
layer
at what layer does migration happen? Yeah.
Oh yeah. So yeah, we kind of migrate at the way down the stack. Like basically, the way to answer the question is like we kind of keep a connection open at the level that you connected at, whether that's a web connection or an SSH connection. And while that connection stays open, we can migrate the VM without losing it. Basically, like we'll migrate the VM, and we might do a redial like behind the scenes, but your connection itself will just experience like hopefully just a couple of seconds of lag at the best, like or at the worst, and then we'll have your VM in another location, so you won't experience anything other than maybe a blip or two.
What is that? What does that depend on? Like the speed of that, like space, storage, or GPU, or what do you?
Could you just repeat the question that he said? Just make it,
Oh,
because
yeah,
people
yeah.
can't hear.
No, we're talking about, I think, the speed of like how either how a VM gets migrated.
Mhm.
Yeah, the speed is pretty fast because basically what we're migrating is mostly your data, and that really is already like we run in multiple data centers. Essentially, like behind the scenes, we kind of built a little mini EBS. Like, so your VM always has like, you're always backed by remote storage somewhere. So really, what we're migrating is just your run state. So we can snap that and kind of move that over. Another good reason to write a hypervisor, and move that over, and then your whole file system and everything is still like there. And actually, we'll do some replication based on like where we move your VM to, maybe. Like we'll just copy, or we'll just maintain a state of like your VMs in multiple locations if you want to pay for it. we can do it, but yeah. So there's we're not migrating much over other than your kind of main run state. If that makes sense.
Yeah.
But yeah, that's.
Anybody have any other questions or anything? I think we're running out of time now. Ooh, well, thanks, man. Really appreciate it.
I'm sorry.
Are you gonna stick around
ChatGPT
and
didn't help me out more.
we can
I
chat GPT
improvise
later.
here.
Are you gonna go to Hack Night?
Yeah, yeah.
Okay, yeah, so go, go bother him at Hack Night with I'm gonna bother you with a bunch of WASM questions.
No, I love it. Yeah.
But yeah,
Like
thanks again.
The function as a service stuff is something we are looking into. And
Okay, well, I can tell you all about that and
Yeah,
why you
let's do
should
it.
or shouldn't do that.
All right.
But yeah, we're gonna go to Hack Night. If you guys could just kind of clean up a little bit, and yeah, everyone online, come back August 1st for another talk. So thanks. Thank you, Neil. All right.